In this video, I'm going to teach you about Chapter 12, which covers linear equations and linear inequalities. Before we start, we need to get a definition, or a couple of definitions. The first definition we see here says, a linear equation in two variables, x and y, is an equation that can be written in the form ax plus by equals c, where a, b, and c are constants. Right, so a, b, and c, those are just numbers. Right, those are going to represent numbers. X and y are variables. Variables mean that these numbers will change. Right, so these are just holding the place of whatever number we choose to put in. All right, so when you see equation, you want to think equals. So a linear equation has an equal sign. We call linear equations linear, or we call this type of equation a linear equation because whenever you graph it, it looks like a line, so linear line. In order for us to graph a linear equation, it needs to be in slope-intercept form. Now this is pretty easy. All it means is that you need to get y by itself. So here you can see slope-intercept form is y equals mx plus b. Now they use m and b here to represent specific numbers. So m will represent the slope, b represents the y-intercept. Right, so the first way that you probably learned slope was rise over run. Right, so that means that the rise is how much it goes up and down. The run is how much it goes left or right. The y-intercept is the place on the graph where the line crosses the y-axis, which is the vertical axis. Once you've got your equation in slope-intercept form, you need to complete the following two steps to graph the line. The first thing you need to do is plot the y-intercept. So if the y-intercept is negative, you're going to go down on the y-axis. If the y-intercept is positive, you're going to go up on the y-axis. Now, starting at the y-intercept, you're going to use the slope in rise over run form to plot the next point. This equation is very important, so make sure you have this written down and that you have it memorized for the test. So let's look at an example. Our first example here says graph y equals negative 5 over 4x plus 6. Our first step is to solve the linear equation for y. Now, lucky for us, y is already by itself, so there's nothing that we need to do here. So there's no numbers in front of y, nothing's being added to y. It's on the left-hand side, it's all by itself. So we can move on to the next step. The next step is to determine the slope in the y-intercept. All right, so we're going to look at our slope-intercept form. Y equals mx plus b. Then we need to identify, or first we need to remember which one is which. So the slope is m and the y-intercept is b. All right, so if you match up your equation with the slope-intercept form, the slope is going to be the number that's in front of x, and then the y-intercept is going to be the number that's by itself. All right, so here we can see that the slope is negative 5 over 4, and the y-intercept is 6. Now that we know that, we can go ahead and graph the line. So here, just like we said before, the first thing you're going to want to do is plot the y-intercept. Then we're going to use the slope to plot the next point. All right, so just to remind you, there's our slope and our y-intercept. Right, so the first thing we need to do is to plot the y-intercept at 6. So that's at a positive 6. So we'll go ahead and plot that. Next, it says that we need to use the slope. You remember we said you should use the slope in rise over run form to plot the next point. Here our rise is -5. This means that we need to go down 5. If it was a +5, we would go up 5. All right, so we're going to go down 5. So let's count. Starting at the y-intercept, 1, 2, 3, 4, 5. Now we need to do the run part. Since this is a +4, only the 5 was negative, the 4 is positive. All right, so since the 4 is positive, and this is the run part, we're going to go to the right 4. So let's count. 1, 2, 3, 4. And then plot your point. Now that you've got your 2 points plotted, the last thing you need to do is just connect these with a line. And make sure that you put an arrow on both ends to indicate that the line continues on in both directions. And that's it. You're done. You've graphed y equals -5/4x plus 6. Next, we need to talk about linear inequalities. Linear inequalities are very similar to linear equations. The only difference is that instead of having an equal sign, they're going to have an inequality symbol. Now, the 4 inequality symbols that we will be using in this chapter are less than, greater than, less than or equal to, or greater than or equal to. All right, so here's the definition of a linear inequality. A linear inequality in 2 variables, x and y, is an inequality that can be written in the form ax plus by is less than c, or it could be with a greater than, or less than or equal to, or a greater than or equal to instead of the less than. Now you'll notice that this is almost the exact same definition as the linear equation, except for the inequality symbol, and that's on purpose. They're supposed to look exactly the same, except for it no longer has the equal sign. Now here are the steps for graphing the regions of solutions of a linear inequality. The first step is to solve the linear inequality for y. This is going to put your inequality in slope-intercept form like we talked about before. If the inequality doesn't have a y, then just solve it for x. If you multiply or divide each side by a negative number, you want to make sure and flip the direction of the inequality. So if it's a greater than, you're going to switch it to a less than. Next, you're going to graph the line. So you're going to graph it just like we did in example 1. This time, though, we'll have to decide if we need to use a solid line or a dashed line. If you have a less than or equal to or a greater than or equal to in your problem, then you're going to use a solid line. If you have just a less than or a greater than, then you're going to use a dashed line. And then the last thing you're going to do is just shade one side of the line. If it's a less than, you're going to shade below the line. If it's a greater than, you're going to shade above the line. Make sure you write this down, have this table memorized. Let's look at an example. Here we have graph 2x plus y is less than or equal to 5. The first step we said is to solve the linear inequality for y. This means we need to get y by itself. So to do that, we need to start by subtracting 2x from both sides. All right, so I'm going to subtract 2x from the left, and then subtract 2x from the right. This is going to cancel out the 2x on the left. Then we're just left with y. You don't have to put the plus if it's positive, you don't need to put the plus. You're just going to know that it's positive. Now we have y on the left is less than or equal to 5 minus 2x. Now, we learned before the y equals mx plus b form, so we usually write the x part first. So I'm just going to flip these around. So instead of 5 minus 2x on the right-hand side, we're going to have negative 2x plus 5. So all I did was just switch the order. And that's fine. You can do that if you're just adding and subtracting. You just gotta make sure and keep the signs with those. Keep the correct signs. Our next step is to determine if we should use a solid line or a dashed line whenever we graph our inequality. So I'm going to pull back up that picture from before, and if you look under step 2 where it says graph the line, it says if the inequality is less than or equal to, which that's what ours is, or greater than or equal to, then you should use a solid line. All right, so we're going to use a solid line whenever we go to graph this. All right, now let's actually graph it. It's going to start off very similar to how example 1 started. All right, so I'm just going to pull back up that picture from before so we can have it as a reference. I would suggest that you have this, sitting beside you as you work on your homework. All right, so here's our step 1, solve the linear inequality for y. Well, we already did that. We got y is less than or equal to negative 2x plus 5. We did that in the last step. All right, so we're moving on to step 2, which says graph the line. The line is described by the equation associated with the inequality. So basically, you just pretend like this is an equation, and we're going to graph it just like we did in example 1. And we're going to remember that we need to use a solid line instead of a dashed line. Again, we're using the solid line because we have a less than or equal to in our problem, not just a less than. Okay, so first thing we need to do is go ahead and identify the slope and the y-intercept. Right, so matching up our inequality here, we can see that the slope is negative 2. But if you remember, we needed this to be in the rise over run form. So we can fix that really easily. If you have just a whole number like negative 2, you're going to just put it over 1. All right, so instead of negative 2, you're going to have negative 2 over 1. All right. And now we can identify the y-intercept. Our y-intercept here is 5. All right, so if you remember from example 1, the first thing we did was we plotted the y-intercept. All right, so here our y-intercept is negative 5. So we're going to put a point on I think I said negative 5, excuse me. Our y-intercept is positive 5, so we're going to plot a point on 5. Next, we are going to use our slope in rise over run form to find the next point. All right, so our slope is negative 2 over 1. So we're going to go down 2 and to the right 1. So let's count. 1, 2. So we went down 2. Now we need to go to the right 1. So there's our next point. Now the last thing that we need to do, if you guys remember, is just put a line through these. Again, this has to be a solid line, not a dashed line. All right, so go ahead and graph your line. Now, we have one extra step here. Our last step, this is like the extra step for inequalities, is to shade in the appropriate side of the line. Now this is really easy to figure out which side you should shade. You can see here on the graph that I have extended the line down. That's just to help us figure out where we should shade at, so we don't shade too far. All right, so for inequalities, you're either going to shade above the line or below the line. If you have a less than or a less than or equal to, you're going to shade to the left or below the line. All right, so this has got to be everything that's less than this line. All right, so on ours, we're going to shade to the left or below the line. If this was greater than, if we had a greater than in our problem instead of a less than or equal to, we would shade above the line. All right, so less than, you shade to the left. Greater than, you shade to the right. Now you have everything that you need to know to go on and complete the homework. If you need some extra practice problems, please see the D2L page and you can look at the extra YouTube videos that I've uploaded there.